Welcome to Sports Science Insight. If you enjoy evidence-based content about training, performance, and recovery, subscribe to the channel and activate notifications. Today, we examine the study titled Dose-Response Relationship Between Evening Exercise and Sleep by Josh Leota and colleagues, published in Nature Communications. The central question is simple. How late is too late to train? This was a very large retrospective observational study. The researchers analyzed more than 4 million person nights from 14,689 physically active adults monitored over 1 year. Exercise, sleep, resting heart rate, and heart rate variability were estimated using wearable data. This enormous dataset allowed the researchers to examine how both exercise timing and cardiovascular strain were associated with sleep and overnight recovery. The study considered two factors together. First, how close did the exercise session end to the participants' habitual sleep onset? Second, how much cardiovascular strain did the session produce? Exercise strain reflected both intensity and duration. Therefore, a moderate but long session could still generate substantial total strain. The results suggest that timing and strain should not be evaluated separately. The most practical finding was the 4-hour window. When exercise ended at least 4 hours before habitual sleep onset, the researchers found no meaningful association with changes in sleep, regardless of exercise strain. This should be interpreted as a practical guideline, not an absolute biological cutoff. Small strain-related differences in overnight autonomic recovery may still occur, even when sleep itself appears relatively unaffected. The pattern became progressively stronger when exercise occurred later and produced greater cardiovascular strain. This combination was associated with later sleep onset, shorter sleep duration, lower sleep quality, higher nocturnal resting heart rate, and lower nocturnal heart rate variability. The findings followed a consistent dose-response pattern. The closer exercise was to sleep, the more its total strain appeared to matter. The magnitude of these associations becomes clearer when maximal and light exercise strain are compared. When exercise ended 2 hours before habitual sleep onset, maximal strain was associated with falling asleep 36 minutes later, and sleeping 22.2 minutes less than light strain. It was also associated with a 3.9 beat per minute increase in nocturnal resting heart rate and a 14.1% reduction in nocturnal heart rate variability. These are associations, not experimentally proven effects. Why might demanding late exercise interfere with recovery? One possibility is that the body remains physiologically activated after the workout has finished. Sympathetic activation, elevated heart rate, increased body temperature, and delayed parasympathetic recovery may make it more difficult to transition into sleep. The lower nocturnal heart rate variability observed in the study is consistent with delayed autonomic recovery. However, this observational study cannot confirm the underlying biological mechanism. What does this mean in practice? If the session ends more than 4 hours before sleep, athletes can generally follow the planned training session. If training must occur within 4 hours of sleep, reducing total cardiovascular strain may help limit the potential disruption. Very close to bedtime, recovery-focused or lower-strain exercise may be the better choice. This is practical guidance based on observational evidence, not a universal prohibition against evening training. Night games create a particularly difficult recovery conflict. Athletes may experience high physiological strain, emotional arousal, bright stadium lighting, travel demands, and a delayed opportunity to sleep. This study did not specifically test professional night games, so this application is an inference. Nevertheless, the findings help explain why athletes may lose sleep precisely when their recovery requirements are highest. Post-game recovery strategies should consider both physiological downregulation and sleep opportunity. The final message is not to fear evening exercise. This was an observational study using wearable estimates in a selected population of active adults. Lifestyle factors such as caffeine, food, alcohol, and light exposure were not fully controlled. Therefore, the study demonstrates a strong association, but it does not prove causation. The practical lesson is to manage exercise timing and total strain together. The closer exercise is to sleep, the more carefully its total strain should be considered.